Hey YouTube, Josh here with Tipsy Python, your casual guide to learning how to program with Python. My goals for today's video are to install a third-party library with pip, and then secondly, we'll use the Pandas library to do some processing on Excel data. And today I'll be sipping on Glenmorangie 12, a sherry cask finish. As a bourbon guy, I feel like 12 years is kind of a long time, but I suppose it's kind of average for a Scotch. It's also notable that this is a single malt Scotch coming in at 86 proof. And it's sherry cask finish. Man, I love finished whiskeys. I'm not even going to count old IPA cask made over there. Let's just say that this is the first real finished whiskey I've had on the show. Just smelling this one a little bit has my mouth salivating. This is such an appealing aroma. I'm excited to get into this one. If you've watched my videos up to this point, I think you're pretty familiar with using the import keyword to import functionality from other modules, but so far, we've just been using modules that ship with a standard library. And the standard library is great. It will get you covered in a lot of cases, but also it kind of makes sense that as people develop Python, we make these cool scripts, we share things with each other, and we want things out there in the community for other people to use. And alternatively, I don't want to rewrite code just for the sake of rewriting it. If someone has code out there that works, I want to reuse it. It's very popular in the Python community and many other coding languages for people to package their code so it can be shared with others. And Python comes with a tool called pip. It's Python's package manager. And pip can be used so that we can download and install these third-party modules and then use them in our scripts. Let's cross that bridge today. Today we're going to be using a data processing library, and we've done some data processing already. If you'll remember back to the video on file handling, we made like a delimiter separated value file and then we processed some inputs from it. Now there are many modules in Python that will help you work with CSVs or databases, but the big kahuna of data processing is called Pandas. I can already hear the comments, but Joshua, NumPy is more memory efficient, has a lot of the same functionality. We're going to use Pandas because that's what I like to use. Now today I'm not doing a deep dive into Pandas by any means. It is huge. There's a lot to learn about it. But view this video just as a sampler of the functionality, what you can do with it, and how you can process Excel data with it. Get your computers ready, get your drinks ready. I'm getting into it. The first thing that I needed for our video today is some sample data. Now I just went to a Microsoft page and they have a financial sample Excel workbook to download. I'll put a link to this in the description below. Now, I'm the cool guys. I don't even have Excel installed on my computer, so I'm just going to show this in Google Drive. Now looking at the columns here, we got segment, country, product, sales, cost of goods sold, gross sales, and some other information. Now, I'm not intimately familiar with this data set, but you don't need to be. Like, this resembles some generic workbook that might land on your desk at work. Now, let's start processing with Python. Like I said, we're going to use the Pandas library. It's a third-party library. It doesn't come with Python. So first, let's install that. I'm going to start at the command line. I'm going to say py-m. It means we're not executing a script, we're executing a module. And then pip, the package manager that comes with Python, and install, and the package name, Pandas. Look, NumPy, I couldn't even get away from it. It's already here. Okay, cool. Now installation's complete. I think there's actually one more optional dependency that we need to read Excel. I'm going to pip install xlrd. Nice, that was pretty painless. Now I'm taking it to Jupyter. Let's import Pandas. Import Pandas, and the convention is as PD. Now before the video, I actually did download that financial sample file, and it's in the same working directory as my notebook. To read this file in, I'm going to say pd.read Excel and my file name. Then finally, this returns an object called a dataframe, so I'm going to set a variable called df equal to the output. Now a brief note here on data frames. A data frame is actually like a matrix style object with columns and rows. It's sort of like an Excel spreadsheet itself. And in the internal workings of Panda, it uses column-based storage for efficiency. But enough of the boring stuff, let's just start using it. Let's try print df. Now this isn't the full spreadsheet, it's a summarized view, but this looks like the Excel data. In this summary view, I'll notice at the very bottom here, it lists the number of rows times the number of columns. We do have a sample of the data. And what's really nice is it actually pulled the column headers off for me, and it's using those as the column names. Now suppose I'm not interested in looking at the summary, but I want to see a single row. I can use the data frame object with iloc along with bracket notation and the index of the row I'm interested in looking at. The data is printed really nicely on the right here. It's formatted for me, and I have all the column names on the left. If I want to, I could just update the row number here and view any of the data set. And if I was interested in a few rows, I could even do something like a slice. Also inside the data, if there's a particular element that I'm interested in, I can use the bracket notation on iloc to look at the row, And then one more time, suppose I'm interested in a particular column, I can look at that too. Here I'm looking at row index 0, and the sales column, there's actually a space embedded in here, and Pandas is returning the value for me. Okay, pretty nifty so far, but it's kind of rare that I want to look at one particular column in isolation. A lot of the times I'm analyzing the entire data set. How do I perform an operation like filtering on sales? Again, really simple with Pandas. The first thing I'm going to do is name a new variable. I'm going to output a sub data frame. And then on the current data frame, I'm going to use bracket notation to do some filtering. I say in this data frame, I want to reference where the column named sales is greater than 1 million. And if I print out this data frame, we'll see in the summary view that it's only containing rows with sales over 1 million. As a little side note here, looking at the number 1 million, it's kind of hard to read. And because it's an integer, I can't put commas in there or it'll mess it up. One nice solution that is allowed in integers is using the underscore. It doesn't actually change the integer value and it makes it easy to read. Now that we've filtered our data set, a common operation would be to iterate through the rows and perform an action. For this, I'm going to reference the sub data frame. I'm going to use the iterRows method. iterRows actually returns a collection of tuples, so let's iterate through those and unpack the tuples like we would the enumerate method. For index row in subDataFrame.iterRows, we're going to iterate through the rows one at a time, and I want to print row sales. Now, I know this is a somewhat trivial example, but I think you see the point here. We went from a spreadsheet that was like 700 rows, and we filtered it down to the results that we wanted really quickly. Pandas and other data processing libraries like it enable us to skip out the grunt work of messing around with formulas in Excel, and we get to do it programmatically. Let's put it all together. I'm going to skip the command line application exercise today because y'all are fairly familiar with those. You know how they work. Let's just create a function that performs some repeatable logic for us that we could actually use in our code. I'm thinking for today's exercise, we'll create a function that reads through an Excel spreadsheet and then looks for, in this case, gross sales, less than some amount, and then prints out a summary report for us. And maybe this is a spreadsheet that I get once a week, so I'm going to parameterize the Excel sheet name and maybe the goal changes, so I'm going to parameterize the comparison value as well. Getting straight into it, I'm going to define a function called findLowPerformers. And we said this is going to take two inputs. One is the Excel file name, the other is the low comparison value. Our first step again was to read the Excel spreadsheet into a data frame. So I'm going to set the variable df equal to pandas.readExcel and the Excel file. And we're not interested in all the rows here. We want to filter them. So I'm going to set a data frame called filtered rows equal to the data frame, and we're filtering on data frame gross sales less than whatever the low value we pass into this function. Now that we have a reduced data set, I'm going to iterate through these rows and print out our information. I'm going to accomplish this with iterRows for index row in filtered rows.iterRows. And here I'm not actually going to reference index, I'm only interested in row, so I'm just going to use an underscore to denote that I'm not interested in holding on to that variable. I'm going to print a formatted string, and it will insert some metadata from each row. And I'll print out something like segment, and then the country, the product, and the gross sales amount. Nice, that function looks pretty good. Let's actually make a call to it. Takes two parameters. First one is our Excel file name. And the second was the low value amount. Let's pretend I'm looking at gross sales less than 2,000. Nice. This output looks pretty good. And it's a lot better than eyeing through there one at a time, and it's a lot better than looking at all the columns. We have just the information we need, and we generated that quickly with Python. And now that we have a parameterized function, I mean, we can do anything with it. We could insert it and use it in one of those command line interfaces that we've made, or we could just put in a script that periodically runs and picks up a data file that we place on our computer, processes it, and then saves the output or emails it or whatever we want to do. You got a lot of options. The world is yours at this point. And again, Pandas is a huge library. This is just a drop in the bucket as far as functionality goes. Basically, any type of data input, you can process it with Pandas. And while I didn't explain everything today, I hope I did give you a couple ideas about how you can use it in the future. Also from today's video, I hope that you see that there's a lot of powerful functionality that's created outside of the Python standard library that you do have to install, but that's very easy to retrieve and use in your code. Now I'll tell you what's easy to enjoy. We got this beautiful Glenmorangie 12 right here. Again, it's a sherry cask finish. I'm not even one to admire the color of a whiskey, but that has a beautiful copper tint. On the nose, you get some sweet caramel and some orange zest. Let's take it to the palate. On the taste, it's like caramel and vanilla with a little bit of toffee thing going on. And probably my favorite and most underrated part of this whiskey is the finish. As I exhale after enjoying it, I get this long, like raisin plum note that lingers in the back of my mouth. It's really delicious. One of the things I like most about Glenmorangie products is their consistency. They know how to deliver a good whiskey. I know that's dependable, and I know where to find this one. I don't have to search all over the place for a bottle. All right, friends, that's it for today's video. As a reminder, if you enjoy this type of content, please consider subscribing to my channel. If you're interested in seeing the Jupyter Notebook, I'm gonna be posting a link in the description below to my GitHub. And as always, friends, until next time, Tipsy Python.